So now another question, but in this case, this is the question. Two pipes are connected in parallel, note, in parallel, between two reservoirs that have difference in levels of 3.5 meters. I have drawn the diagram here, 3.5 meters. The length and the diameter and the friction factor are 2,400 meters, 1.2 meters, and 0.026 for the first pipe, and 2,400 meters, 1 meter, and 0.019 for the second pipe. Calculate the total discharge between the two reservoirs. So what do we know? We're given the length, diameter, and friction factor for both pipes, and I have written them out here. The length of the first pipe is 2,400 and the length of the second pipe is 2,400 meters. The diameter is 1.2 meters and 1 meters, and then the friction factor is that. So now how do we solve? These pipes are connected in parallel. So how do we solve them? How do we solve this question? Well, we know that the total head loss HL will be equal to HF1, which is now equal to HF2, because the total head loss is equal to HF1, which is equal to HF2. This is because they are connected in parallel. So we were asked to find the discharge, that is Q. So that means that it will be easier and more preferable for us to use the formula that involves Q. So now writing this expression again, now we have HL will be equal to, for HF1 we will have 32 F1 L1 Q1 square over pi square G D1 raised to power 5, which will now be equal to 32 F2 L2 Q2 square over pi square G D2 raised to power 5. You may ask, why is Q1 not equal to Q2? And the reason is because both pipes are not the same pipe. How do I put it? Okay, you can see that this pipe has an inlet here and lets out here, and this has an inlet here and lets out here. These two pipes are not really connected together like the case of series connection. In series, let's see, where is the question? In series, I'm trying to look for the question, okay, or the explanation. In series, we have all these pipes connected together basically as one, but in parallel there are two independent pipes. So in series, the flow rate here, or the flow here, the discharge here is the same as the discharge here, but in parallel the discharge here is the same as the discharge here, but it's not the same as the discharge in the second pipe. So the discharge is independent to the pipe, and we note that the diameter of the two pipes are different. That means that their velocities will also be different. So now this is our formula, and now let's go forward. We know HL. I've told you that HL, or the general whatever for HL, is 3.5 meters, like the difference in the two reservoirs, in the water level of the two reservoirs. So HL is 3.5 meters, will now be equal to 32 times F1. F1 is what? 0.026 times L1. L1 is what? 2400 times Q1. Q1 is what? Unknown. Q1 square over pi square times 9.81 times D, the diameter, 1.2 raised to power 5, and this is equal to 32 times the F for the second pipe, that's 0.019, then the length for the second pipe, that is 2400, and the discharge is unknown, that's what we are looking for, over pi square 9.81 times 1 raised to the power 5. Now let us solve one by one, because we are asked to find the total discharge. The total discharge between the two pipes, or between the two pipes, that is the total discharge into this tank here, will be Q1 plus Q2. So because that it will be Q1 plus Q2, because both of these pipes enter that tank. So now we'll have this, and we'll solve them individually now, picking this first. So now 3.5 will be equal to 32 into bracket 0.026 into bracket 2400 Q1 square over pi square 9.81 1.2 raised to the power 5. So now make Q1 squared the subject of the formula. So Q1 squared will be equal to what? 3.5 times pi square times 9.81 times 1.2 raised to the power 5 over 32 0.026 times 2400. Exactly, that's 2400, and this will give us what? 0.6498. But if I find the square root of this, 0.42, I'm sorry, the answer is 0.4223. But if I find the square root, it won't give me what is in this note. So let's see, where did I make a mistake? Oh, friction factor is 4F. That means that we would have to divide the friction factor we're given by 4. Let me scroll up. That means we will have to divide the friction factor we're given, this and this, by 4. So basically this is 4F. So friction factor will be this over 4. Let me erase some of this. Over 4 and over 4. So basically, when we have what we have here, is not correct, because it will have to be over 4. So I'll just add that 4 here. Sorry for the confusion. Over 4. Don't make that mistake. Read the question very well. Over 4, and this can just cancel here. 32 divided by 4 will now give us 8. So that means this will be not be 32, it will be 8. Okay, and then the answer now, let me calculate it. 1.689, and if you find the square root of that number, Q1 will now be equal to 1.29 meter cube per second. And now to find Q2, let us go back. So now remember this equation, we consider the second part of the equation with 3.5. So to find Q2, sorry, not like that, 3.5 will be equal to 32 F2 L Q2. square over pi square g d2 raised to power 5, and this will be equal to 32 times f, that's 0.1019. remember this is over 4, so I'm just going to put that here, times pi square times g times the diameter is 1 raised to power 5, then multiplied by the length 2400 q2 square, and that will give us, so now let us make q2 the subject of the formula. q2 square will be equal to 3.5, so basically this cancel this 8, 3.5 times pi square times g times 1 over 8 times 0.019 times 2400, exactly, times 2400. So now this will be equal to, let me put that on my calculator, 0.9289. so we have q2 and we have q1, so the total discharge q will be equal to q1 plus q2. Oh sorry, this is still the square, so q2 will be equal to square root of this, let me find that, which is 0.96 meter cube per second. So total Q will be equal to 1.29 plus 0.96, which will be equal to 2.25 meter cube per second, and that is the solution to that question.